Welcome back to the channel. Hope everybody had a good Christmas and a happy new year to everybody. I'm going to kick off 2025 with this first video, which is going to be an overview of these VDE torque screwdrivers available to me in the UK. We have here the system from Armeg. This one is from Teng Tools. This one is from Draper Tools. We then have one from Engex Tools, Teng Tools, Wera, and then finally Wiha. We'll take a quick look at the screwdrivers and show you some test results from the Ghidorah Dremo Test E over there. So we start off with the system available from Armeg. This has a 1 to 6 Newton meter range in 0.1 Newton meter steps with a plus or minus 6% tolerance. It's available to you in two kits. You have a half kit, which is calibration certificate plus the torque screwdriver handle plus 3 blades and the setting tool. That retails for around about £100 to £120 in the UK. Or you can purchase the full kit, which comes with the calibration certificate, a torque screwdriver handle, a T-handle, a standard screwdriver handle, setting tool again, and 9 different screwdriver blades. That will set you back £162. Both these kits come in the blow molded case with this foam surround for protecting the actual tool itself. Overall, there's a total of 14 different screwdriver blades available with the Armeg system, and they are available as replacements or spares for a cost of around about £7 each. The T-handle and the screwdriver handle are also both available as spares. However, I couldn't find the torque handle and the setting tool available as spares on their own. They're only available within the kits. The system is made in Taiwan. And the results table here, you can see there is a little bit of an issue with this screwdriver. Now, this screwdriver is my own. I have had this screwdriver for around about 4 years. I would estimate that it's on around about 1,500 to 2,000 operations, somewhere around about that region. So we've not reached the 5,000 operations recommendation of the ISO standard for calibration, but obviously it is a bit older than 1 year. But you can see that as I've progressed through the testing, it's slowly got worse, especially down at that 1 Newton meter mark. And then it kind of extends out into the 6 Newton meter by the end of it. We were 1, 2, 3, 4 readings out of tolerance, and the average was also out of tolerance after 1,000 operations. So it does look like this screwdriver is actually on its way out of calibration and will need replacing, as I presume they are sealed units and cannot be recalibrated or repaired. Setting of this screwdriver can be achieved with the blade inserted into the handle, and you take the setting tool, insert it into the top of the handle there, and you set the dial to the mark on the side to whatever setting that you want, and hopefully you can hear this clicking around. So there's a set position for each setting. Next screwdriver we have is from Teng Tools. This has a 1.5 Newton meter up to 3 Newton meter range. In the kit you get the torque handle itself, a 6mm hex setting tool, you get a posi 2 blade and a posi 1 blade, and it all comes in this little wallet. I did not get any calibration certificate. I also cannot find any VDE certification either. On the markings on the tool, only the blades have VDE rating. The handle has no VDE rating whatsoever. Now, this would have set you back about £150. However, it has been withdrawn by the manufacturer. So now it's just whatever stock is remaining within tool suppliers, and then once that's all gone, this system is no longer available. And both the blades are available individually for around about £16 each. And the system is made in Germany. Tools are inserted and are more of a friction fit than a locking, as per a lot of the other suppliers. And to set it, you put the key in the top of the handle, and there is a mark that you can see on there that you line up with the dial around the outside. Again, each position just clicks into and stays put. Just put up the table for the test results on the drummer test for this tool, and you can see it's actually done really well. We ended up with a spread of 1.3 to 2.9% after 1,000 operations. So it shifted a little bit from the original test, but that's all well and truly within specification. No issues there whatsoever. I did get a little misreading at 1.5 Newton meters on the 500 operations test. That could be me, although all those readings seem to have crept up a little bit in comparison. But yeah, sometimes using the drummer test, if you get a slightly different angle or something, you can affect the reading a little bit. I perhaps missed that one. But other than that, all the averages are pretty much within range, and there is no concerns with regard to the accuracy of that screwdriver. So in that respect, it is a good buy. This is the XP1000 from Draper Tools. Has a 1 to 5 Newton meter range, plus or minus 6%, and is in 0.02 Newton meter steps. Comes in two kits. You have the 9-piece set, which retails for around about £76. In that you get the torque handle, you get 8 blades, you get a test certificate, and a brief little instruction sheet. There's also a 19-piece set out there, which retails for around about £83, and in that you get a torque, a screwdriver, and a precision screwdriver handle, and then you get 16 blades, again along with a test certificate and a brief little instruction sheet. All of these blades that come in the kit are available individually for a cost of around about £5 each, and some of the blades are also available in a slimline insulation version as opposed to the stepped insulation that you see on this blade here. However, there are no different type of blades other than what's available in the 19-piece kit. There doesn't appear to be any availability of the torque handle on its own. You can only purchase that within one of the two kits. And I believe it is all manufactured in Taiwan for Draper. The torque setting can be adjusted with the blades inserted into the handle. When they're inserted, they're locked into position and they can't remove. You have to pull back on the collar to remove them. To set the tool up to the required torque, you have a combination of the window here and the scale around this setting nut. The nut is currently locked, so you can't accidentally adjust the setting whilst in use. To release it, you pull it forward and then you can turn the handle. And as you turn the handle, the scale here will rise. This is in 0.5 Newton meter steps, and on the dial here you have 0.1 Newton meter markings, but then you have a 0.2 Newton meter graduation in between each of those markings. And again, set to whatever torque you like. You can push the handle back into position to lock it, and then it won't move whilst you're using the screwdriver. So I can put the test results table up for this Draper screwdriver, and you can immediately see I've got quite an issue with this unit. At 1 Newton meters, we do have a few that are in specification, probably about 50-50. After the 1,000 operations, that's very, very similar result, average of 6.9% to 6.7%. However, the main issue is at this 3 Newton meter and 5 Newton meter marks, where all of the results are out of tolerance, just over 9% on average for those test results. Now this is a brand new screwdriver, it's not second hand or anything, so I'm not 100% sure what is happening with that really. I guess on the optimistic side of things you could say that it is over tightening rather than setting things too loose. As long as you're not stripping threads or damaging casings and the like, then I guess that's the best way to be. But I was quite surprised at these results from a company which is a fairly reputable manufacturer these days. Next up is this offering from Engex. If you've not heard of Engex before, and I hadn't before I got hold of this kit, they are a UK tool supplier who sell their products through city electrical factors within the United Kingdom. They are an electrical wholesaler within the UK. This is a 1 to 6 Newton meter unit, plus or minus 6% in 0.1 Newton meter steps. Comes in this blue wallet and it retails in CAF for around about £115. For your money, you get the screwdriver handle itself, the torque handle, the setting tool, certificate calibration here, and you get 12 blades. And looking at this, this looks exactly the same as the Armeg unit, just different branding on it. There's the Engex logo there. So it works in exactly the same manner as the Armeg unit does. The units are totally interchangeable as well with one another, which is just as well because this is all you get from Engex. There are no spare blades available, there are no extra blades, torque handle isn't available separately, you can only buy it in this one kit. But in operation, the blades lock in place and then you twist to unlock and they can be removed. Set the tool easy enough with the blade installed, and you have the dial around here that you line up with the mark, exactly the same as the Armeg, and it clicks around into whatever setting you want, and then you're good to go. The only slight difference I can see between these two units, we have our Engex one here on the right and our Armeg one here on the left. Well, you can see if I can get the light out of it. The dial on this one seems to go further around, the graduations go further around the circle than they do on the Armeg unit. It seems to be like 3/4 of the way around, and seem to go a bit further around on the Engex unit. Also, the Engex unit stops at 1 Nm and 6 Nm, whereas you can see the Armeg unit goes slightly past. But that's the only real difference, other than a little bit of marking on the blades. You can see they're slightly different, but that's not much to worry about in that respect. As I believe this is made by a company in Taiwan. They hold the VDE certification for it, and I presume they just rebadge it for Armeg or Engex as required. So I put the results up here for the Engex screwdriver. You can see originally we started out with a spread of minus 0.8% to 1% on average. Initially a very good result. As we've gone through the number of operations and increased them from 500 to 1000, you can see that we have drifted a little bit from the nominal value, everything ending up below that as though it's not tightening up as much as it was, but they all remain well within specification, so it doesn't look like there's any issues with this unit. That of course indicates that there is perhaps a little bit more a problem with my original Armeg unit, and it's looking like that is definitely starting to fail now in comparison to the Engex unit here. Next one up is from Teng Tools, who are a Swedish tool company, but this is manufactured in Taiwan, as a lot of their insulated tools appear to be. They make the one screwdriver with a 1 to 5 Nm range, plus or minus 6%, and a 0.02 Nm step. This kit I have here is their 9-piece set. You get the screwdriver handle itself, you get 8 blades with slimline insulation to them, and you get the calibration certificate, all in this modular box that is designed to go in their roller suitcases. This particular one will set you back about £130. However, they do exactly the same kit but in a foam tray to go in a tool drawer, but that's £150. They also do a VDE toolkit that this is part of for £420, also in a foam tray. This is also the first company that we've got where they will offer all of this as individual bits. So you can get all these blades as individuals, but there are only the 8 type of blades available for around about £7 each. They will also sell you the torque screwdriver handle on its own, although it does come in a blow moulded case, its own blow moulded case, which will retail for £110. Now this is a very similar design to the Draper system in operation. You take the bits in there, they will lock in place, and then you pull back on the collar to remove it. The setting of this is exactly the same. You have the nut here that you pull out to release the mechanism, and then you can turn it up in ½ Nm here, 0.1 Nm digits on the nut going around, and then these little graduations in between are 0.02 Nm, so you just turn it up in ½ Nm for turns, so there's 2.5 Nm, and lock it shut and you are good to go again. So moving on to the test results for these Teng screwdrivers, you can see here down at the 1 Nm We are a little bit out, again giving the impression that it's over tightening. As we go up to 500 operations, again, we're over tightening a little bit. The reason why the average is showing red there and none of the actual readings are red is because the readings are compared to the min-max values, which includes the resolution on my Ghidorah Dremo test, whereas the average is just being compared to the standard 6%. So you do get that little kind of odd looking error where the average is over tolerance but none of the individual readings are. As we go up to 1000 operations, you can see that's actually got a little bit better. 1 Newton meter is still a little bit out on average, and we do have a couple of readings that have gone over the maximum value expected. But at 3 Newton meter and 5 Newton meter, they're all within spec, so they seem to be fairly good in that respect. So this is the offering from Wera Tools. The total range for their products goes from 0.3 Newton meters to 3.5 Newton meters, plus or minus 6% in 0.1 Newton meter steps. However, that is spread across 3 different torque handles. The torque handle I have here is the 7441, 1.223 Newton meters for this particular one, costs in the region of £110. It's the most popular version of their torque handle out there. There are 2 other versions, a 7400 which covers 0.3 to 1.2 Newton meters, and a 7444 that covers 1.7 to 3.5 Newton meters. They will sell these torque handles just on their own, so they just come in a little cardboard box. Certificate of conformance, which is really the actual calibration data there as well, so that's all good. You can buy sets with the 7441 handle in it. A 15-piece set costs £158, comes with a handle and 14 different blades, and then the 16-piece set is the same except you have a standard screwdriver handle with it as well as the torque handle. Overall, this has 27 different types of blades available for their system, but that's also in slimline format and this stepped standard insulation format. You also have a number of stainless steel drivers as well. As far as I know, Wera are the only one that offer stainless steel interchangeable driver blades. Everything is made within the Czech Republic. Blades are locking into the handle on this little recess, push all the way in, and then they will not come out until you pull back down on the collar, and then they will remove. You do have a spinner on this particular one, so you can spin should you want to. Do something up loose. Torque setting is on this nut here that spins to prevent you from accidentally changing the torque, and then when you want to, you pull down on the collar, you hear it click and lock, and then you can turn the handle, and you have a range there that you can see. You might struggle to see this. It's really difficult to see in poor light. It's gone into focus there, and you can see just a set of lines there that you line up with the arrow on the torque handle itself, and you're then good to go. I forgot to mention as well that all the blades are actually available independently for £6 each, or around about that value. So you can pull up the test results for this Wera. You can see that everything is in tolerance, and there isn't a massive amount of deviation over the number of operations either. It's moved a little bit, as you would expect a screwdriver to do, and they are kind of loosening up, because again, as the screwdriver wears in, I would expect the torque setting to loosen up a little bit and to not tighten up as much as it was. But you see there, initially you had minus 1.5 to 2.1% across the range. You're now at the end of 1000 operations, minus 1% to minus 3.8%. And this unit is a brand new unit that I purchased specifically for this. Last system we're going to look at is from Wiha. They offer a torque range from 0.6 Newton meters all the way up to 7 Newton meters, which is the largest range of all the screwdrivers. However, it is across 3 different handles. All of those have a plus or minus 6% and in 0.2 Newton meter steps. The 3 handles are 26625, which is 0.6 to 2 Newton meters, 26626, which is 0.8 to 5 Newton meters, and the 26627, which is 2 up to 7 Newton meters. The screwdrivers themselves, they come packaged with torque handle, the adjusting tool, the adapter for the 6mm blades, and the certificate. They all come in little plastic sleeves like this. They range from 236 all up to 275 pounds. However, this kit that I've got is a 5-piece kit, which is the 0.8 to 5 Newton meter handle, and that comes with the handle, the case, and the certificate, along with a PZ slotted 1 and a PZ slotted 2. That's the most popular way to buy this kit within the UK. Part number for that kit is 38074. You can also get a 15-piece set, which is again this 0.8 to 5 Newton meter handle, and you get 14 bits with that overall, and it all comes in a wallet. That's for £158, and then for £177 you can get that same kit, and as well as the torque screwdriver handle, you get a standard screwdriver handle with that. All of the bits are available individually, and there is over 45 different bits for the VDE system, so it's got the most extensive range of bits. You can buy them individually for around about £7 each, or you can buy them in kits of 6 for around about £35, and they come with a little plastic holder like this, or you can get them in a 12-bit set which comes with 2 holders and a belt clip for around about £50. The yellow ones that I have here, they're for their electric screwdriver. However, they're still 6mm and will fit inside these torque adapter handle for the screwdrivers. You can also get a socket adapter for this, 1/4-inch socket adapter that will fit into the screwdriver handle, and you can get a total of 12 sockets from 4 up to 14mm. Again, VDE is the only one I know that has a manufacturer's VDE rated 1/4 drive adapter for their screwdriver system. I'll also add in that you can get from VDE these fixed torque adapters as well. They come in boxes of I think a set of 5, or you can buy them individually. They're around about £40 each individually, so they're quite expensive, but it allows you to fit this into a standard screwdriver handle, and you have a torque limiting adapter to go with that. They are also available. Setting on this screwdriver, you have to use the tool, and not only do you have to use the tool, you have to remove the bit holder that normally slides in there. You have to remove that because the tool inserts up inside the handle. I'm not sure how well you can see this because again it's a very small window. It's spring loaded, so if you just put it up against it, it doesn't lock. You have to push up and in, and then it'll lock, and then you can turn and you see it adjusting. Hopefully it adjusts up in 0.2 Newton meter steps, so we're on 1.2 there. If you wanted 1.3, go around to 1.4, you'd have to come back and sit in between them, and then when you're done you put the adapter in, and then you can put the bit in, and this collar here you push forward and it locks, but it also acts as a spinner collar as well in a similar manner to the Wera system. But of course you got it, once you want to change that again you have to take all this out, and then you have to set whichever torque setting you want, and you're good to go again. The only thing that I have noticed is when you put this in and you lock it in, you can knock this collar back, and that puts it in to release the bit, so then the bit is very loose and will drop out. You can also do that if you're working in a panel. I've caught it a few times on the edge of the panel, and again it knocks back quite easy. That might be because it's getting a bit old, because this is one of the screwdrivers that I do use. It's about 4.5, coming on 5 years old now. But that's the system. We'll take a look at the test results for this one. And you can see from the tables that everything is all in the green with this screwdriver. Now, this probably already has around about 1500 to 2000 operations when I did the initial test, and we were 1.9% up to 4.8%. As being our tolerance more at the 1 Newton meter, and then as we get up to the 1000 operations, our spread has dropped from 1.8% to 2.3%. So it's got a little bit tighter for some strange reason. Not sure why it would get better as you increase the number of operations, but there you go, that's what's in the tables. We'll just put up this table as well for the torque adapters themselves. You can see the different values that you can get there, from 0.8 up to 4 Newton meters. I don't find that these have quite a positive operation as the normal torque screwdrivers do. It's quite a gentle clicking that you get from them. They are all within tolerance, only at the 0.8 Newton meters. We have, overall we're in tolerance. We had one that slipped just out of tolerance, 0.895. As I say, these do operate to 10% tolerance rather than the 6% tolerance of the screwdrivers. You need to bear that in mind as well. So we'll just take a little look at interchangeability between the systems. We can deal with the VDE unit first because it doesn't have any interchangeability whatsoever. These bits or blades are 6mm across flats, and they will not fit in any of these other drivers. They will also not fit in a standard quarter hex drive as well. I'm not sure how well you can see this. Whilst they do go in, they will move around a lot, and it's actually biting on the edge of the blade here, the corner of the hex. I've got a feeling that would burr over very easily if you used it in that manner. So not much good at all in that respect for that one. Armeg, Engex and CK all operate on a 6.35mm across flats, so these are totally interchangeable. I can take blade there and it will fit in there. I can also take the blade from either the Armeg or the Engex, and that will fit in there and that will actually turn. With regard to putting them in the Armeg or Engex handle, whilst they do fit and they do lock, you're left with an awful lot of play. You have to put the handle right up in there, the drive must be at the head here, and you're left with an awful lot of play around this area. The blades there from Engex kind of lock in place and pad that air out, so you may be putting undue strain at this end and causing damage to it in the long term. So probably not a brilliant idea. As a standard 6.35mm quarter hex, the quarter hex drive will fit and will go in there, no problems. Again, this rattles around, so you may be putting undue strain there. If you had a little 3D printer, you could perhaps emulate that and put this around here and lock it in place, and that would be better. The other thing to bear in mind, of course, is that you are no longer VDE at this end. Whilst your handle stays VDE, it doesn't with regard to the bits. But if you wanted different bits, that may well get you out and may well be a solution. I did try magnetising this as well, and just to see if it would lock in place, but it doesn't. This doesn't appear to be magnetic in the top of the handle at all, so that didn't work. As the CK is more of a friction fit, this will go in and it does lock in and stay in, and it seems fairly robust. So that could be an option for that, but obviously no longer VDE and even more metalwork exposed, and this handle isn't VDE rated either. Draper, Teng Tools and Wera. These all operate on a 9mm across flat drive, and the Teng and Draper, they look exactly the same. They have slightly different part numbers on them, so you can't guarantee they're exactly the same, but dimension wise they look to be directly compatible. And we've got Teng Tools there, goes in Draper and it locks in place and just releases okay. Likewise, Draper goes into Teng, locks in place, comes out no problem. Either of these will fit into the handle from Wera, and they lock in place, no problems there. Or they do bounce around a little bit, but they don't pull out completely. You have to pull back to remove. Blades from Wera, they are slightly different. They are actually longer, and you can see where cut out for the locking peg, whatever's inside is in a slightly different place. So whilst these will go in to either unit, they won't lock. They will just pull straight out, but it's quite a tight friction fit. Goes in again. So you can use them. They do seem to work all okay. And obviously they're independently VDE rated, so there are no problems with that issue. Comparing these in length, the shortest system that you can get would be from VDE. If you use their dumpy screwdriver, one of their torque adapters and their standard blades. You'll get here, you're around about 150mm long for that one there. That's the shortest way you can get a VDE torque screwdriver. Then move up to the CK unit, which is 195-ish, around there. Then the Armeg and the Engex are both the same size, and about 230mm. Slightly longer is the VDE unit, which is coming at 240-ish. And then doing this the long way around, aren't I? Then you move on to the Wera, which is about 295, and finally the Draper and the Teng are both about the same size, and they're about 310mm long. So if it's compactness you're after, you need to look down at the VDE system. If you're not concerned, then obviously any one of these will be perfectly acceptable. So that'll be it for this video. I'm definitely going to revisit the Draper screwdriver and try and find out what the issues are with that one. I may do another video on something like the VDE to show the complete system of what's available, and the Wera screwdriver as well, the bits and pieces that I've got. But thanks for watching. If you managed to make it this far, hope you found it useful. I'll leave you with a little summary sheet of the VDE torque drivers that are in this video, and I'll see you again in the next one.